In this video, I'm going to talk about the order of operations and the distributive property. Now, the distributive property has a lot of awesome applications, and in this video, I'm just going to talk about one of the applications, which is mental math, but we're going to start with the order of operations. So, as most of you know, the order of operations is grouping symbols first, and that would be things like parentheses, a fraction bar, brackets, the absolute value. And then after that we have exponents, and then we have multiplication and then division, but these actually go left to right, and so multiplication isn't necessarily first, but these happen left to right. So if the division happens to the left and then the multiplication is on the right, then we do it in that order. So I'll explain that as I show you an example. Same thing with addition and subtraction. It also happens left to right. So it's grouping symbols, exponents, multiplication, division, and then addition, subtraction. So let's do a couple examples on that. We'll start with 30 divided by 3 plus 2 times 6. Okay. So with the order of operations, we have three things that we need to check out. We have division, addition, and multiplication. And so the order of operations would tell us multiplication and division go first. Since the division here is on the left, we're going to do that first. So 30 divided by 3 is 10, and then we still have that plus 2 times 6. Now the order of operations says got to do that multiplication, so now we have it's 12, and the 10 is still there. And then finally we have the addition, so we should get an answer of 22. Let's try another example. If we have 30 divided by 3 plus 2 times 6, notice the same digits are here. We have a 30 and a 3 and a 2 and a 6. Same operations, but now we have these parentheses here telling us, hey, do this first. So now we have this 30, and we're going to keep that there for a moment. Division we'll keep there. And then this 3 plus 2 we have to do, so that's 5. And then we have this times 6. Now the order of operations after grouping symbols will tell us to do division and multiplication left to right. So we'll start with the division. And then we have the last remaining thing, which is multiplication. So as you can see, the parentheses definitely change the answer. Alright, let's try another example. Let's say you want to buy 2 magazines at a cost of $3.99. So 2 magazines at a cost of $3.99. But you also want to buy 3 greeting cards that each cost $1.99. So this could be an expression that would help you figure out how much your total cost is going to be. So the 2 magazines at $3.99 each, that's going to cost $7.98. So we're going to do that. And the 3 greeting cards at $1.99 each is going to cost $5.97. And now we add those together and get, let's see, well, let's try it. We got $7.98, $5.97, and I think it should be, what, $13.95 or something? Let's see. 19, $13.95. There we go. And this, we were talking about money, so let's make sure we answer in terms of dollars or cents or something. Okay, and let's do one more order of operations problem before we move on to distributive property. Let's try 9 plus 3 times 5 minus 1. So remember, pause this one, try it out, and then resume. So the first thing I'm going to do is this 3 times 5. And so that leaves the 9 plus 15 minus 1 still there. Now addition, subtraction left to right. So 9 plus 15 is 24. Minus 1 is 23. So when you're doing your work on Monday, I'd like you to show your work in this way, showing the steps that you go through to get the answer rather than just doing it in your head. That way, if you make a mistake, your partner or your group member can help find out where that mistake is. Whereas if you had just gone from here and gone right to there, then we wouldn't know how you arrived at that answer. All right, let's talk about the distributive property real quick. So the distributive property tells us if we have any numbers A, B, and C, that if you add B plus C and then multiply it by A, that would be the same thing as multiplying A to each thing individually first. So let me show you an example of that. So if you had 3 times 5 plus 4, it equals 3 times 5 plus 3 times 4. So order of operations, traditionally you would just say 5 plus 4, which is 9, and then times 3 would get you 27. Over here, if we had done it with the distributive property, we would see that 3 times 5 is 15, and 3 times 4 is 12, and then it also equals 27. So the distributive property is used like that. Basically, it says take this thing that's being multiplied to both to the sum of the stuff inside, and then just multiply it to each thing individually first. This also works with subtraction. So if let me move this. So if this was subtraction, so A times B minus C, it would look very similar, but there would be a subtraction in the middle here. Okay, so why is this necessary? So the cool use of the distributive property here is, and let me switch to a new page. Let's say you wanted to multiply 7 times 59. We could do that. We could say, well, 7 times 59, and most likely we'd probably need to do it like this and say 63, carry the 6, 35, so 413. And that's fine. But if you notice that 59 is really close to 60, you could set it up like this. Okay, and what that does is allows us to use distributive property mentally. Oops, didn't want to move that. Oh well. So this is going to allow us to use the distributive property mentally. And what the distributive property says is, instead of doing 60 minus 1 first and getting 59 and multiplying by 7, we can do this multiplication separately. Well, 7 times 60 is real easy. We can do that in our head. That's 420. And 7 times 1 is easy. We can do that in our head. That's 7. And this is pretty easy to do in our head. That's 413. And so even though I'm writing it down to explain it, this is what you would do in your head very quickly rather than getting a pencil and paper and having to do this on paper. So we can try another example of that. So let's say you wanted to multiply 7 times 52. So again, this is probably a problem that most of you would do on pencil and paper. But using the distributive property, we know that 50 plus 2 is the same thing as writing 52. It's kind of the reverse. Instead of adding them, we're kind of breaking it apart. And then the distributive property says, hey, let's multiply that 7 times each thing individually and then add them. So 7 times 5 is 35, so 7 times 50 is 350. 7 times 2 is 14. And so we get 364. Again, I'm writing this down, but I'm writing down a thought process that once you practice the distributive property, you'll do in your head. You won't need pencil and paper. And I have to say, this is like so useful. I use this every day, and it's really going to speed up your calculations if you look for opportunities to use the distributive property to break up numbers and make them easier to multiply. That should be it for the video. Thank you.